Hi, my name is Rohit Pasula, and this is my video for Physics 2, Lab 1, Charged Tapes. The objective of this lab is essentially to observe and calculate the excess electric charge on one piece of charged clear Scotch tape, as well as to visualize the physical behavior that the different charges have on the tape. We will create a computational model through a program called GlowScript and determine the calculations needed for the magnitude of the electric charge. The fundamental principle demonstrated throughout the lab is Newton's second and third law of motion, as well as Coulomb's law. The concepts of electric field and its resulting force are prevalent in this lab too. The procedure of the lab includes creating a U-tape. To do this, you take two pieces of tape, set one as the base tape, and place another on top of it. Then quickly remove the tape that's on top. To make sure that the tape is negatively charged, use a plastic pen and observe the repulsion that occurs. Now repeat those steps with another pair of tapes. Finally, hover one of the U-tapes over the other and measure the distance of separation. This value for us was 1.8 centimeters, or 0.018 meters. Now, before heading into our computational model, there are a couple assumptions that we must address. For the sake of the model, we will be assuming that both pieces of tape are completely identical in size, shape, and matter. This also means that each tape has exactly the same charge. We will be viewing the tape as point charges. Regarding other forces that may be involved in the experiment, they will be negligible, most importantly, air resistance and drag force. Now, before developing the code, we must set the constants and variables corresponding to them. These constants include g, the gravitational constant, which is 9.81, the length of our tape, which was measured to be about 18.1 centimeters, or 0.181 meters, the mass of the tape, 1.81 e to the negative fourth, as well as the distance of separation that we observed between the two charged tapes, 1.8 centimeters. The mass of an atom and electron was also calculated and recorded in order to determine the number of excess electrons. Regarding the actual code used to calculate the magnitude of the electric charge, I first found the magnitude of the electric force on the top tape. Using this number, as well as Coulomb's law, I determined the charge of the tape. I have also calculated the number of excess electrons and atoms per electron using the tape's surface area and the mass of each of them. So as you can see, the model generated is to the right. The magnitude of the electric force on the top of the tape is approximately 1.8 e to the negative 3. The charge of the tape as a whole is about 8 e to the negative 9. The number of excess electrons was about 5 e to the 10th, and atoms per electron was 8 e to the 6th. So, for our reflection questions, what if electrons had a positive charge and protons had a negative charge? What would change? What would change about the observations you made with your tapes and other charged objects? So, regardless of whether the tapes are positively charged or negatively charged, they will still repel each other since they both will have the same charge. This is due to the basis that like charges will repel. This is similar to the situation with the pen, as well as since the charges will just be flipped. Now, why is it important to handle the charged tapes as little as possible? What happens when the charged tapes come into contact with your hands or other objects? The charged tapes are supposed to be handled with minimal contact from other surfaces, including our hands, due to the reason of maintaining their charges. We are at risk of causing the tapes to lose electrons, as electrons will transfer to a more neutral surface. The excess electrons that the tapes hold might be lost, ruining the experiment in the process. As a result, during the experiment, I made sure to make very little contact with the tape, holding them only in the corners. This prevented the electrons from transferring to my hand, which would alter the charge of the tape. Thank you for listening, and have a wonderful day.